Today's lecture is 7th, Making Semiconductor. We deal with oxidation with chlorine-containing gas. This method is halogen species dueling oxidation, so reduction in metallic contamination and improved SiO2 and Si interface properties. This is divided into parts, linear and parabolic. Even if you put a lot of HCl in both of them, there is no metal on the surface. There is segregation coefficient, which is equilibrium dopant in silicon per silicon oxide. First, put on the boron and dopant diffuses slowly in silicon oxide. Although the dopant exists from silicon to silicon oxide, there is a relatively small amount of diffusion at the interface due to the small amount of diffusion in silicon oxide. Second, fast diffusion in silicon oxide. At the interface there is a lot of amount, but this picture is shown because it is diffusion soon. Third, when we put on the dopant phosphorus, which is N-type, dopant diffuses slowly in silicon oxide. So compared to the amount going from silicon to silicon oxide, the amount of diffuse is smaller and accumulates. Finally, fast diffusion in silicon oxide, which is put on the gallium. The diffuse rate is so fast that there is no slope in silicon oxide and silicon interface is low. As a result, heavily doping increases growth and thickness in the same amount of time. There are two types of doped silicon: diffusion and ion implantation. The process is to pre-deposit and heat it to drive-in. Here is a diffusion system, and here is mathematics in diffusion process. So the result of the various formulas show that as the distance from the surface increases, the amount of doping increases, but the area increases when there is an infinite resource. Also, in a limited resource, even if the distance is far from the surface, it has the same area.